As a strategic partner of Esri on the evaluation of utility network, Avinion has in-depth understanding of the value the utility network can bring to a utilities and communications industry. Understanding the value of this new evolution of GIS is the first step to considering Esri's utility network. Esri's new utility network is more capable than the geometric networks currently used by electric, gas, water, wastewater, and telecom companies. Let's see. At the fundamental level, junctions and edges remain the core to new model and store connectivity. However, utility network changes the way junctions and edges are categorized for connectivity. The categorization is done using asset groups and asset types, unlike the subtypes previously used with geometric networks. Now that we understand the categorization, let us understand the differences in the networks. In a geometric network, connectivity cannot be organized into hierarchies. In contrast, utility network enables managing connectivity as network types, tiers, and subnetworks. The tiers support topology types such as radial, mesh, and multi-feed. For instance, subnetworks provide the ability to model a circuit within an electrical system or a pressure zone within a gas system. This marks the first reason why utility network is more capable than geometric networks. Now, let us move on to the mechanics of how connectivity is put together. For those of you familiar with configuring a geometric network, the connectivity rules allowing which junction or edge can or cannot connect with another are defined at the subtype level. With utility network, these rules are set up a bit deeper using asset types. The ability to define connectivity rules at a granular level marks the second reason why utility network is more capable than the geometric model. Connectivity does not mean much if you are not able to use it for tracing. So let us look at the differences. When tracing, the weights within geometric network provided the intelligence and cost of taking one path versus another. This capability is significantly expanded with network attributes in the utility network. Network attributes provide for a scalable way to trace energy or resource flow, such as phase, pressure, or voltage, as well as recognize identity, such as circuit or pressure zone. Network categories provide a configurable way to implement the role played by junctions and edges as sources, sinks, and controllers for managing the flow. The utility network also provides propagators to maintain network attributes across subnetworks and tiers when assets and connectivity changes in the field. The freedom from proprietary and custom tools for subnetwork management makes this the number 3 reason that utility network has significantly greater capability than geometric network. Now let us look at something very intriguing. For those of you who can remember, a physical connection between your computer and the LAN port on the wall used to be the only way to connect to a network and the internet. As we all know, such physical contact is no longer needed with the proliferation of Wi-Fi and Bluetooth. With geometric networks, physical and geometrical contact between junction and an edge was crucial for modeling connectivity. Relationships were the only other way to model two junctions as connected without physically showing an edge connecting them. Such relationships were not represented in the geometric network and, as such, were useless for tracing or controlling the flow. Similar to what Wi-Fi did for internet connectivity, utility network shatters this limitation through associations. Associations provide a way to connect two junctions without physically having an edge between them. On a related note, utility network also offers containers. Containers provide an easy way to hide away localized connectivity details to produce more readable views and map products at scale. The details can be toggled on when tracing and updating the connectivity. This is the 4th reason utility network significantly outperforms its predecessor, the geometric network. Are you ready for the last in our list? With utility network, junctions can have in and out terminals. It is a smart way to represent incoming and outgoing ports on equipment without actually drawing ports as graphical features on the map. Terminals are the implementation of network graphs and logical connectivity gateways. This makes it possible to emulate multidirectional flows at a junction by simply placing equipment as a point in the map and specifying the terminal configuration. This compelling feature does not exist in geometric networks and is an important capability to many utility end users. For these 5 reasons, hierarchy, granularity, scalability, associative connectivity, and graph connectivity, we think Esri's utility network offers significantly greater capability compared to the traditional geometric network. This capability, when rolled out as apps, will lower costs, drive innovation, and improve the user experience of GIS users at every level. We hope you have found this information helpful. You are welcome to visit the below websites for further information.